With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In this question, we have to find out the volume of the liquid flowing per second across the cross-sectional area of the tube. This question is related to viscous force. What is viscous force? Viscous force is actually frictional force acting on a liquid. For example, if this layer of liquid moves with velocity v minus dv and this layer of liquid moves with velocity v, let's say this length from base is z and this thickness is dz, then on this liquid the frictional force is going to act in this direction, and on this liquid the frictional force is going to act in this direction. That frictional force is actually equal to minus of eta viscosity multiplied by area over which the friction force is applied and multiplied by velocity gradient dv over dz. Now, this same concept can be applied for the given cylinder. Let us consider that a distance of r, we take a cylinder of thickness dr. Let us consider this length as L. Therefore, the expression of frictional force on this cylinder can be written as F is equal to minus of eta multiplied by area on which friction force is present. Let's say on this layer it is in this direction and on this layer it is in this direction. We can say therefore that minus of eta multiplied by curved surface of this cylinder, which is equal to 2 pi r multiplied by L multiplied by dv over dr, considering this lower layer moves with velocity v and this upper layer moves with v minus dv. Finally, because this liquid is in steady flow, therefore the net force on this liquid will be 0. Let us say if friction on this liquid section is net in this direction and the pressure force is in this direction, which is PA, then this frictional force should be equal to pressure multiplied by area. Since pressure is applied on these faces, therefore we will be taking this area for multiplication, which will be P multiplied by pi r square. Therefore, minus of eta 2 pi rl into dv over dr gives us P into pi r square, which is the given expression. On integrating this equation, we get function of velocity as this. That is, at every small r, that is the radial distance from the center, velocity is different. Therefore, to find out volume flow rate, we will have to consider at a general distance r, a thickness of dr. This is our cylinder, let's say. The length is L. Therefore, we can say that the total volume flow rate will be the total area, this, multiplied by the velocity at this radius V0. Therefore, the volume flow rate for this small section, let's call it df, will be equal to 2 pi r dr multiplied by V0 1 minus r square over r square, which is the volume at smaller radial distance. This implies that df is equal to 2 pi V0 r minus r cube upon r square dr. If we integrate this equation in the limits 0 to r, and this will therefore give us total volume flow rate. Let's call this F. So total volume flow rate will be equal to integral 0 to r, which is 2 pi v naught multiplied by r square by 2 minus r to the power 4 upon 4 r cube, with the limits 0 to capital R. That will be the total volume flow rate. This implies that volume flow rate through the entire cylinder will be 2 pi v naught multiplied by r square by 2 minus r to the power 4 by 4r square. This is square. This implies that total volume flow rate will be equal to 2 pi v naught multiplied by r square by 2 minus r square by 4, which gives r square by 4, which is equal to pi r square v naught over 2, which is option number B. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.